Hello, welcome to this session about event-driven architectures and OpenTelemetry. My name is Anton Rodriguez. I work as a principal software engineer at New Relic. I'm very focused in Kafka platforms, and in general, data streaming. If you don't know New Relic, it's a company providing monitoring as a service for other companies and help them to implement observability patterns. We are heavy users of Kafka, and it's in event-driven architecture really huge, just in hundreds of gigabytes per second and millions of messages every day. So today I want to speak specifically about event-driven architectures, the typical problems many companies have with them. For that, I'm going to use this example. It's a very simple pipeline, but I think it's good enough to understand those problems. So what we have here, it's an application producing messages and sending those messages to a topic called orders. In this particular case, it's a Java application, and we are using Kafka to store that information. And from there, we have a Kafka Streams application. This is a framework for streaming applications. It's consuming from the topic orders and sending the information to another topic, maybe in a different cluster called billing. And now we have the consumer application in the right, which is reading that billing data and ingesting that information in a database. So the customers of this pipeline can query that information, and maybe they can create alerts and things like that. The thing is, someone has reported the process is too slow. In some cases, it takes a lot of time for a specific message to go through the whole pipeline and arrive to the database. So as engineers, we want to fix this particular problem. But because there are 3 different applications and 2 different topics involved, it's quite hard to know where is the problem. It may be in the producer application, in the Kafka streams, in the consumer, maybe in some of the topics, in the clusters, maybe it's a combination of all of them. So it's not really easy to see where we should focus to fix that particular problem. For that, we can use distributed tracing. So the idea here is every application in the pipeline is going to send traces to our monitoring system, and we are going to put all together to know what's the latency in every stage of the pipeline, and we can calculate the overall end-to-end latency thanks to that, identify what part of the pipelines are requiring more time to process a particular message. So distributed tracing is a well-known pattern, heavily used in microservices architecture with web services and HTTP and synchronous communication, but it's not so well-known with event-driven architectures and in general asynchronous communication. So what I want to show here today is how to use it in that context and how powerful it can be. The thing is also distributed tracing can help us to identify the problem, but it's not so helpful to help us to fix the particular problem. For that, there are more traditional ways like metrics or logs. In the particular case of logs, if there is an error in some of those applications, like, I don't know, we have out of memory and our application is restarting all the time, logs are super useful. But if it's not an error, it's just an optimization problem, then logs are not so useful and metrics are usually better. In this particular case, we are going to use the Kafka client metrics. Kafka in the client side provides a lot of metrics to be able to identify and do proper tuning and optimization of our applications. So we want also to use that to fix our particular problem. Now, how we can have both things, distributed tracing and metrics in our applications. One way, and this is very interesting and pretty new, it's OpenTelemetry. What is OpenTelemetry? Okay, so OpenTelemetry is a standard, an open standard. That's the first thing, and that's great because as every other open standard in technology, it allows us to use different tools, different vendors to move and to easily migrate between them and to contribute back to it and improve it over time to our particular use cases. So we have a standard, but there is also OpenTelemetry tooling, which is totally open source, and we can use it, we can contribute back to it, we can adapt it also to our use cases. So OpenTelemetry, it's the standard and the tooling. And now in this session, we are going to see how to work with the tooling specifically. So what we're going to take a look is to the OpenTelemetry Java agent. A Java agent is something we deploy with our application. It's able to understand our application, to see what is using under the hood, what frameworks, what libraries is being used by our application, and to generate metrics and traces for that particular framework. So in this case, using the OpenTelemetry Java agent, we are going to be able to generate Kafka metrics and distributed traces. And this is kind of, it's almost like magic. We add it to our application. It's able to identify what we are using and to generate both things, the metrics and the traces. So it's really very powerful because it provides a lot of information out of the box. And if we need specific traces or we have specific use cases, we can also modify our application to have this type of manual instrumentation and be able to extend the Java agent with more functionality if that's something we need to do. In this particular presentation, we are going to see how it works out of the box because it provides a lot of information. So how we can start to use the Java agent? This is really simple. It's just 4 environment variables in our application. The first one is the Java ops variable, and we are going to tell when you use Java, add this particular Java agent. It's just a jar file we can download from Maven Central or from the OpenTelemetry repositories. And then we define 3 more variables to identify the endpoint. So basically, where is our monitoring solution, where we are going to store our metrics and traces, some headers for authentication in this particular case, and we can also add some metadata, like for example, the service name or the environment, if we have a test, a production environment, and things like that to easily identify the metrics in our monitoring tool and be able to explore them and to use them properly. So that's all we have to do. We have those variables, we download the Java agent, we redeploy our application, and boom, now we have distributed tracing in place. So OpenTelemetry, it's a standard. It doesn't provide an UI. So you have to use a specific vendor or an open source application to explore the metrics. In this particular case, we are using New Relic because I work for New Relic. And what we can see here is now the monitoring tool is able to identify all the applications involved in my pipeline. So on the left, we can see we have a producer 1 application, which is sending data to a Kafka Streams 1 application and then to a consumer 1 application. So we are able to see all our pipeline just in an automatic way from the traces. And it's not only that, it also allows us to send how much time we are spending in every step. So in this particular case, it's very clear the offender, it's the producer 1 application because it's taking around 1.47 seconds to send the data from the application to the topic orders. So we don't need to think about the Kafka Streams 1 or the consumer 1 application. What we are going to do is to focus in that particular, in producer 1, and to try to figure out why it's taking so long to send the data to Kafka. So going deeper in producer one, we can see all the messages and how long it takes for every of them. So in the beginning, it takes a lot of time, like 6 seconds, and slow it down. This is a normal behavior in Java and Kafka applications, because in the beginning there is some warming it has to do and open connection and so on, so the messages take longer. But after a while, we see this pattern of 5 messages, and every 5 messages, it's the next message is taking longer, and then it's taking less and less and less, and then 5 messages, and it's taking longer again, right? So if you're familiar with asynchronous communication, this is well-known pattern. It seems like a queue. So basically, we have the first messages arriving to the queue, and the second, and the third, and the fourth, and the fifth, and then we send all of them, and we start again, right? So the first message is taking longer because it needs to wait for the other 4 to arrive, right? So seems like there is a queue somewhere in our producer one application, which is generating this artificial delay. So let's try to figure out where is that queue and how we can configure it to reduce the latency in the application. And for that, distributed tracing is not so useful. For that, we need to go into the internals of the Kafka library. Specifically, we want the Kafka metrics. So in the agent, it's really easy now to have Kafka metrics. It's just these 2 lines of code. So you add the library, you create the Kafka telemetry object, and then you put in the producer properties, the specific properties for OpenTelemetry and the metrics. So there is nothing more you have to do. Recompile the application, redeploy it, and now you have Kafka metrics in your monitoring tool. This has been contributed to the OpenTelemetry Java agent by New Relic like 1 month ago. It's very interesting because now you can have logs, you can have the Kafka metrics, and you have distributed traces all together provided by the Kafka agent in a quite efficient and performant way. So we do that, we redeploy our application, and now we have all those metrics. So on the left, we can see the list of them. There are more, just some of them. There is a lot of very interesting things like the compression rate to identify if there are problems with compression, the number of connections, or failures in authentication, and so on. In our particular case, we are looking for a queue, and there is a specific metric, record queue time average. So if we take a look to it, we can see in average all the records in Kafka, in the Kafka client, are taking around 1 second waiting in that queue, right? So it seems like it's aligned with what we are seeing in distributed tracing, because it's taking, in overall, you have those 5 messages, and they are waiting different time, but in average, it's around 1 point something seconds, right? So going a bit deep on of the metrics, we can also find this other metric, records per request average. And we can see this metric is around 5-6 messages per request, which is aligned with the pattern we were reviewing of 5 messages each, right? And this is a very good indicator of, okay, we have 5 records per request, and that means we are waiting for 5 messages to send a request to Kafka, and it's aligned with what we have been seeing in our distributed traces. So it seems this is not maybe the problem, but a good indicator of the problem per se, right? So we now, following the metrics, we know there is a queue, we know there are 5 records, and we have a concept of request, and we are sending 5 records per request. So now it's the time to go into the official documentation of Kafka and see how we can change that behavior. So if we do that, we can validate that Kafka is indeed doing a request to send all the messages to the Kafka cluster. And that request is just different messages all together, right? So the Kafka producer is waiting for all those messages, and when some of those conditions are happening, it sends the messages all together in a request. There are 2 conditions. One is batch size, so how big is the request? So if we define, for example, batch size of 1 megabyte, it's going to wait until there is 1 megabyte of messages to send the request. But there is also linger.ms. And linger.ms is how long it's going to wait. So if we hit the batch size or we wait more than linger.ms, the Kafka producer is going to batch all the messages together and it's going to send them to the Kafka broker. So in this particular case, it seems like we are hitting one of those. And that's something we can see in the metrics, and we can also take a look to the configuration in our application. And that's something, that's what we did. We take a look to linger.ms and we discover it's pretty big. So we reduce linger.ms, we redeploy our application, and we take a look to the distributed tracing again to see if that fixes the problem. And that's what we found. This is before we changed linger.ms, and that's after. And now we don't see that pattern of 5 messages. What we see is every time a message is arriving to the queue or is ready in our producer one application, we are sending it directly to Kafka, and we are not waiting for other messages. So we reduce the end-to-end latency of our pipeline. Now, just a warning about this, that this doesn't mean you should reduce or change your linger.ms configuration in your application. Okay, this is a very important parameter. It helps to increase the throughput or the latency, depending on what you want, and also it can reduce a lot the load in your Kafka clusters. So depending on what you want to do, how you want to optimize your applications, you may want to choose a value of linger.ms or another one. The important thing here is to understand the different metrics, how they are related, and then base it on that, change that particular configuration. Just a couple of things more related to distributed tracing for event-driven architectures. One of the main problems you can have with distributed tracing is it can be very expensive or generate a lot of load in your monitoring tooling. And the reason for that is because if your pipeline it's a high throughput pipeline and you are processing millions of messages and you are generating a trace for every message in the pipeline, that can be quite costly because you have to process all those traces and store them in a database, and that takes a lot of resources. So interesting feature you can use in the OpenTelemetry agent and also in other tooling, it's sampling. Instead of generate a metric per every message, you only do it for a subset of them, and you can define how big is that subset. In that way, you don't have a trace for every message, but it should be significant enough to understand what is the bottleneck and the problems you have without to spending a lot of resources to have this in place. So it can be quite interesting to take a look to sampling if you just want to reduce the amount of traces your applications are generating. Most of the time, there is yet a lot of value on it, even if you don't have all of them. That's all from me today. The summary is for event-driven architectures, take a look to distributed tracing. It can be very, very helpful. And you can use OpenTelemetry and specifically the Java agent. Really easy setup, and it's going to provide a lot of information out of the box, metrics, logs, and traces. Particularly for Kafka, now you have also Kafka metrics. So it's a really easy way to take a look and to understand how to improve and tune your Kafka producers and consumers. That's all from me. Thank you very much. You have comments, questions, or feedback in general. This is my GitHub account. And also there is a GitHub repository with the demo, so you can run it by yourselves, integrate it with different monitoring tools if you want. It's available in GitHub. That's all from me. Thank you very much.